Okay, so this is Coffee Compiler Club. Anything to do with compilers, language runtimes, garbage collections, concurrency, typing systems, security and code. I don't know what all, performance of all kinds. Is all fair game? You're being videoed, videos show up on Twitter. These days, between a day and a week. So you'll be live. If you don't like it, bail out now. Open mic. Ask what you want. I reserve the right to moderate. Never had to do it. That's my opening spiel. This afternoon, I'm going to talk to my tax person. So I've got my afternoon laid to waste already. And nothing else hugely exciting is going on. I'm doing SQL TCPH queries in the old H2O code. You know, the goal being just how fast can these things be made to go? And interesting numbers. So I don't know if it counts as compilers or not, but I'm at least the first 6 queries, I'm easily faster than the best reported single node solution. But of course, I don't have an actual SQL query engine, so I'm hand rolling all my queries. So I'm cheating out the wazoo. If I get a query engine to produce the query that I'm writing, then I think I've got it slam dunk done. And,
what did you say about TCP, Cliff?
TCPH, yeah, queries, yeah.
Is that like related to TCP/IP or completely different?
No, SQL.
Okay. What does TCP stand for in this context? Transaction
Processing Query.
I see.
I'm here. This is the current query I'm working on in the chat, right? It's SQL. So this is an easy one in that it's actually like a big ass for loop where you just filter a bunch of lines and then you do a product and a sum. And then the one that I burned all day on yesterday to get an answer that took me forever to get something that looked competitive, and I thought it sucked, and then I went compared to everyone else sucks on this one too. This query is much more brutal because secretly in the where clause, it says some customer key and table customer and customer key and table orders have to be equal. So find all the records where those two are equal, and the line number order key matches the order number, and the line number supplier key matches the supplier, and the customer nation matches nation, and the supplier nation, blah, blah, blah. Okay, what the hell is it saying? It's saying find clients and suppliers that are in the same nation, find the set of orders that they pass between them, limited to some region, which is Asia, limited to a year date, group them by nation and by revenue, and then sum up the revenue per nation. So what you're asking is there an interesting amount of revenue had between my clients and suppliers within any individual nation such that I might want to set up a local distributor within that nation, as opposed to using like a Europe-wide warehouse distribution network. So maybe there's some special rules. If I go to Poland, I'll get, you know, a Polish specific warehouse that just handles Poland to Poland traffic. That's what the query is sort of angled at. How you actually implement it, it's take these 5 tables, find things that are equal in this pair of tables, matches this pair of tables, matches this pair, and this pair, this pair, this pair. That's a hell of a thing to go sort without being sort of brutal about it. So I got brutal about it, and I kind of sucked. So I got more clever with data structures and got something reasonable. And then I looked, now I'm very competitive, but I would have claimed that my answer sucked, but everyone else's answer sucks too. So there you go. It's a compiler problem down at the bottom, but there's a ways to get there. So that's what I spent my week on. Somebody else's turn, unless you want to dive down this path even more.
I've done quite a bit of work with SQL, but I wouldn't have connected that to you, Cliff, and what you do, because it's such a low level that you operate at. You use a whole terminology I've never even heard. So this is interesting to see. Why would anybody try to write? So you're writing some kind of SQL compiler that makes sense of this?
Yeah, I have a client who is writing a database with an alternative, not SQL syntax language. But it's declarative like SQL. So they have a compiler to generate imperative query plan from a declarative query description. And their performance sucks, and they know it. And they know some of why it sucks. And they have implementation issues, and they had language design choice issues. And there's a bunch of things we're going back and forth on. And now one of the open questions is, replumb your data structure for speed. Is it worth it? What would you do as a different data structure? So I said, well, great to H2O. It's great for doing, big data math. H2O is not a database, but it can run a query like nobody's business. So can I make a Java version that does the query that looks sensible? I could auto-generate from a query plan generator from a query compiler, but run it on H2O, and would it be worth it? So I'm handwriting a bunch of queries. And like here is query 6 is simple, and I have it wrong. So, take it with a grain of salt. I'm currently busy debugging query 6. So here's my harness to run query 6 missing the key bit. So I've preloaded the data. That's SQL line frame. I pick columns. Okay, column picking is a constant time operation. This just names the column headers. The data doesn't come with any freaking column headers from TCPH people. I run this new filter sum. What the hell is that? Well, that's a one-liner wrap around a map reduce task, which I'll show in a second, that computes the query sum. Okay, now I have this dang thing where I do, let me show you the inner loop. Here's the map call, which says, for I equals 1 to length. Okay, this is auto-parallelized, so the length is not, what you see for the length is not the whole of the data, it's a fraction, so I can run it in parallel. Which means there's a reduce, which I'll throw down here, which just takes the sums and adds them. So in parallel with a different check in the data, go grab the date, do a date check. That's up the top. I says ship date is between interval and interval plus a year. That's my low and high date have already been a year apart. Grab the quantity if it's less than 24. Grab the discount if it's between this range. Sum it. Multiply and sum. So that's, I think I can auto-generate that query. The thing I did for query number 5, I would have trouble auto-generating. It might be doable. It gives a much better plan than my first cut at 5 was do the obvious thing. I did joins. H2O does joins. So you do table join. Join. Well, the joins get bigger. Then it gets slower. Suddenly I'm tied with
yeah, you better filter as you're cross-producting or combinatorics will crush. You better filter as you're cross-producting or the combinatorics will kill you.
Yeah, so query 5 doesn't do any filtering except right in the beginning. I did all the filters up front. So it just does the region is Asia and the order dates within a year. So first thing you do, you filter those. Now, because nation and region and actually suppliers are pretty small, I just pre-joined them already because that was multiple queries use that. So I filtered the pre-join thing, that's tiny. Then I joined nation, region, supplier. I think I joined it with customer. And that took like a second. No, with orders. I had customers thrown in there. It's like free as well. It's too small. Then I threw order count and it became like substantial, like scale factor 1 that took a second by itself. And then I joined it with line items and becomes 2 more seconds. Then I run the group by fraction of a second. So the query runtime is 3 seconds, 3.5 seconds, of which 3 are joins and a half is the original filter and nothing in anything else. And 3.5 seconds puts me competitive with state-of-the-art databases on single nodes with 1/3 the hardware. I have a 20 hyperthread. I'm looking at somebody else's numbers. They have 72 hyperthreads. So then I changed the data structures to drop the second big 2-second query join, and suddenly I was 1.8 seconds, which beats state-of-the-art. But I did a cheaty data structure hack. It wasn't cheaty, but it was like unusual. And I'm debating that I can teach a query compiler to do that. And where do you want to go from there? So this is H2O writing, the filters are all easy. The sums, the group bys, they're all easy. The joins, I call a join thing. It's as good as somebody else's join thing. You suck at forgetting big data big quick.
I'm trying to think how you minimize the traffic on the join.
Yeah, joins suck, which is the whole point. They're easy to think about and easy to write that query. I just want to find all the customers whose orders match the orders, and the orders came from a supplier in Poland, and the customers lived in Poland, or just the nation. So I want to have a triangular equivalency relationship between a bunch of tables. So that's conceptually easy to think about. Now implement a join. Well, the obvious bad, good, whatever you call it, implementation strategy is you sort the join columns, and then you walk the two tables, and when you get a hit, you pick up all the columns from one table and you add them to the other, and then you walk forward as a merge sort, right? If they're unequal, you take you bump. If they were equal a second ago, you bump them both. If they're unequal, you take the guy who's behind and you bump him until he's ahead, and if he's ahead, you bump the other guy until they tie, and as soon as you tie, you throw the columns in. The problem that is a merge sort like that's linear. Big data, you want to be parallel. Now you want to be distributed. Your data spread around.
What if they're not in a list, but in some kind of skip list? So I can be like, this guy's halfway through the data space. Let's split on that and continue from.
Right. So you said
sort of a radix sort.
So the data is, I have a column of data. Do I sort it or not? And then separately, there is, how is the column represented? I have a bunch of rows, a bunch of columns going across. Pick a column. Do I sort it or not? It's the first question. If I don't sort it, how do I get two guys to find that they have the same? So the other strategy for one table small is you hash it. You throw all the rows into a big hash table, hashed by the key column in question. And then you hand that out to every possible chunk of the big data, and you walk all the rows in the big data and you do a hash lookup. You get hit in the hash table, you got a hit. You take all the rows, you got them in. So that works if the small table is small, and fails if the small table is actually still very large because you can't fit them in a hash table. So for instance, I have two tables I'm joining. They're both larger than fit in one machine's RAM. So I have them on a cluster, but I cannot put all of one table on any one machine. So I can't use the hashing approach. How do you do it? Right, and then how do you do it efficiently? But how do you do it at all?
If I store both sets of rows as a trie, where I've got some prefix that I'm looking at, that should be able to fork out relatively efficiently, where I'm just like, okay, do you have this first 5 bits? Do you have that first 5 bits? Do you have that first 5 bits? And fork 32 ways each time you go down the tree, and then merge on the other side.
Yeah, so something similar. So that starts by saying I need to be merged so that I can have adjacent bit patterns near each other. And so I have to be sorted so I can have adjacent bit patterns near each other. And sorted is already a big problem. But let's say we sort them. And now it's what we do in H2O. We have them broken out in chunks. You called it a trie. I just have a in-way, like a B tree, except the in-way split it's one layer deep and the in-way is big. But considered a B tree, instead of two-way split, I did a 1,000-way split. And then I have a chunk of 1,000,000 rows that's sorted within it and sorted to the next chunk, which is its own 1,000,000 rows. And I have 1,000 of these 1,000,000 row chunks. That's one column. Now I have this other column I have the same behavior with, but some of the data is on other nodes. And I have to like line them up, but there's no guarantee that any one node has the same data from any one guy. So there's an alignment thing that has to be sorted. And then once you have two things of roughly a similar alignment, you can start playing the merge sort game. I don't know. Does that sound what you're trying to propose? I mean, that's what I did.
It does sound like what I was trying to propose. I just wasn't sure whether sorting, is there any advantage to like sorting on a hash of the data rather than sorting on the data, so it's at least denser?
Well, it has to be, you have to find.
We're only finding perfect matches though.
Yeah, right. I don't think it makes any difference because the sort, that's an interesting proposition. The time on the sort is not the key compare. You have to have the full key so that you didn't shrink it any. You made a hash, it was a new piece of data, but it was small. Now you're looking for perfect matches on hash.
My interest was not small, my interest was uniform. The keys may be really dense in some parts and really sparse in other parts, so I can't really sort on the tree. But if I have a good hash function, now I can say, okay, I've got 20 nodes here, they each get a 20th of the data. I'm just going to take the first 5 bits to split it 32 ways or whatever.
Assuming uniform distribution out of your hash function.
Of my hash output.
That's an interesting proposition. Assuming uniform distribution, every node has roughly near equivalent amounts. Or else another way to look at it. So here's the deal.
It starts to look like Chord or Kademlia.
If they actually landed after the sort on the right node, they wouldn't have to data, wouldn't have to move, except at the edges where you're never perfect and you always move some. But in my implementation strategy just assumed that they weren't ever going to align and you just had to move the data anyhow. But you can move it in small chunks. Unlike the hashing thing, you could handle moving a chunk of the data from some node to you, do your comparisons, and then throw it away. And then grab another chunk from another node, which you'd have to do in your hash. But if you had good distribution, most of the time, people would be mostly on the same node. That's an interesting, I don't know, that's a statistical, you just made a statistical argument for a weird kind of sort.
Yeah, it just assumes that your hash is pretty good random.
Yeah. Assuming the hash like does something sensible. Stupidly, in this case, these numbers are all linear, 1, 2, 3, 4, 5, 6, 7, 8, 9, so they perfectly align for all order key, line numbers, and whatever. But the output of the other column you're joining against are all random scramble. Actually, that's a good point. They are still random scramble then. And sort, I would take a hash would be the line number directly, or the order number, or the supplier number directly, because those are dense counts of 1, 2, 3, or 5. So it doesn't help this query any because you're just going to sort on the column. It's the same as sorting on the hash. Sorting on the hash would make more sense if you had, as you said, big gaps. The data itself is not, I mean, it's densely packed. So 2 adjacent rows will have, monotonically increasing because you sorted, but they might have giant gaps in the numbers. That's fine. There's no holes in the presentation of the data. I don't know. I'll have to put it on my bag of tricks.
Yeah, the thing I'm trying to get around is if it's an arbitrary bag of strings, it's like a file system, and it turns out that almost all the files are in /users / something.
Yeah, right. You get a bad distribution. Yeah, I got it. And then, but I lay them out linearly in a sorted order. If I did them with regular sort, lay them out linearly in a sorted order, but I have bajillions of them. So the first 10 nodes in the cluster have /users / yada, yada, yada for billions. And the last 10 nodes have /home, /Cliffsy, /home, /Kirk, whatever, yada, yada, yada. And you get this funny, heavily weighted distribution, but it's still the same billion things spread, packed on 20 nodes, divided at 20th intervals. But many of them all start with saying /user, /var, /blah, blah, blah. You have a giant prefix before they come around. So file names is not a good one. URLs is a better one. There you get this very huge prefix, interesting middle, and the suffix is always .html, .csv, .cs file, .js, whatever. There's a couple of suffixes. The prefixes are 100 to 1,000 characters, all identical, and there's a little piece in the middle that's different. And their sorting is expensive for the string compare and mostly a waste of time because your first 1,000 characters are all identical anyhow. And you'd rather maybe hash and then sort on the hash. So that's interesting. Yeah. And then the sort goes faster because the hash comparison is a long that you're just going to compare two longs and be done. Sounds like a thing to me. Oh, and Flavio's not here. So the other thing went around, that's what happened last week. The other thing went around was we were talking about loop fusion. And Flavio hit a roadblock, and I was thinking it should be worked aroundable. And then realized in the video replay what his problem was and realized that I had hit the same wall 20 years ago and also gave up on it. And it's because of the exact, I don't know, exact's not the word, the model that Java has for memory side effects. If I have two loops, loop one, loop two, and loop one is going to fill an array, which starts with zeros and puts good data. And you go to loop two, and it's going to fill its sister array with zeros to good data. And you want to fuse the loops because they're run in parallel, and you're not going to read from one right to the other. You just want to compute it once and put it in the second one, maybe. The issue is if you take a safe point in the middle of the fused loop, you won't see all of array one done. You'll see half of array one done and half of array two. So if those arrays have escaped to the outside world, another thread can see a misordering where they'll see a prefix set, a tail of zeros on array one, and a prefix set and a tail of zeros on array two, and that's never a valid Java state. Except that maybe if you don't have any synchronization going on, you could argue that you're allowed to get arbitrarily out of order.
Do you have an opinion on compilers that ask the user if it can do things where you're like, hey, you said collection.map.map.map.map. My runtime profiling says this is really expensive. If you let me change it to collection.map function 1 and then function 2 and then function 3, right, this will run 100 times faster. Consider if you can change this, and it will mess with your side effects, but the developer knows.
Right. I don't know. Like the only people I've seen that actually do this would be like the vectorizing compiler guys, where they can ask who got vectorized and who didn't. And then when you didn't get vectorized, the compiler wouldn't give you a suggestion of what to do, but it would say, I could not vectorize this because.
Yeah, I think that's the job of like a lint tool or you know, or a program advisor or something else, you know, that you do separate from compiling, trying to help you reorganize your code.
Right. The compiler's taking what you wrote and dealing. And if you turn on extra lint warnings in your compiler, you do, and you get those warnings, including, hey, this looks like dumbass code.
But in the same way that, so you talk about you want to be able to say, this thing should never be auto-boxed.
Yeah.
Make sure that you let me know if you're going to box this thing.
Right.
You might say, hey, this collection is my big collection. Don't do any linear scans of this. If I'm ever linear scanning the thing that I've tagged as big, warn me.
Okay, so that's a language semantic change. You have declared the language warnable, or if warns are errors, it's an illegal language.
Yes, probably more of a suggestion for AA than anything we could do to Scala at this point.
Right. Yeah, that's fine. People have compiler flags all the time that change the language meaning. That's a common thing. Ignore all warnings, don't ignore all warnings, whatever, you know, casts are allowed or not. In C, there's a C++, there are different kind of casts you allow or you don't. Yeah, the hard part there is actually having a compiler do a good job at recognizing from the low level. I think what Keith was saying, you know, the advisor guy looks for actually a map call as a keyword. Like map's not a keyword, but I can look for a map and have a special pattern match rule that says, I see map.map.map.map, and you've asked for, you know, folding map collection messages pop up. What I'm thinking for AA is that I tag it on a data structure as a type. So this is a, you know, a final const star collection of blah, but when you one more tag on there that says big, and big tag means I expect it to get large and, as you said, make asymptotically good choices on how I deal with the collection. Linear passes are probably okay. I don't want anything that's n squared though. Like if I want to touch the entire collection, it's linear. I can't not do that. But if I do a sort with, you know, bubble sort, that's n squared. That's ugly. So now deduce algorithmic complexity. There are people who do that, but I'm not yet in that zone. Rendezvous hashing, is that the hashing hack that you were talking about? Somebody threw it in chat here.
It is. Mostly I've seen it for people who are trying to get a bunch of clients to be pinned to a server, and the servers are coming and going at some relatively slow rate compared to the clients coming and going.
Oh, I see. I see. Yeah, I do. Okay, here's consistent hashing. H2O does I called it a consistent hash. I don't know. It's a hash that guarantees take a range of data and round robins them around a cluster with good distribution and no hotspots kind of thing. So your key for any given chunk of data is a key and key value store. The key had a hash that told it what node it home to. The home forced to go around. Collections of the same length picked up the same hash, the same layout, so that the rows would be aligned on the same node without any further ado. And that was sort of the, you know, key performance hack, is that you can go across and you have a 2D table that's trillions and bigger than a node. So, but you can go across a row for free because they're all on the same node, because they've all hashed to a consistent target. But I don't know, Rendezvous is a little different here. I have no idea what Rendezvous is, how it's different. Some sort of weighted hashing to see you land on stuff. Yeah, it's fine. The other thing I was doing with hashing was picking a second and a third node in the cluster for your backup data pieces. You had, you know, three-way replication. You first was your main for deciding correctness and consistency, and you had a second and a third. And then if the node changed shape, who was your second and your third, and did you lose one of your replicas, and where do you go for the next one, and that kind of stuff. Okay, what else? It's all very quiet today. Our usual talky people aren't here.
I'm still thinking about your comment about sort of the merging the two loops and being a violation of the, you know, the Java's memory model. If nothing is synchronized, or whatever word you want to use, then I mean, I don't see it any different than a compiler reordering to assignment statements, right?
Right.
Just
It's then
to-
ordering the entire. Okay. Here is maybe the difference. Maybe it's not a difference we can live with. In the land of Java, you are allowed to throw an exception at another thread, including one that can't ever happen in the context of that thread normally.
And how do you do that?
I'm sorry. You do. It's called Thread.def, Thread.stop. There's some thread API that you can throw. Like the goal was to let a thread manager manage a pool of threads who got wedged somehow.
Sounds like the goal is to do the moral equivalent of pkill on Unix systems.
The goal was what?
To do the moral equivalent of pkill on a Unix system. Hey,
Yeah,
this process is not
yeah.
happening. Please
Yeah, well, there's
send a kill.
thread.interrupt. Maybe that's what you're thinking of, or
Let me pull it up here. I just got the thing here. There's a call.
Yeah, I'm also looking for it, but I think on newer JDKs it's not even there anymore.
Really, that was a huge major, like, no one ever used it. It caused such grief.
Yeah, it was a call which also allowed you to introduce checked exceptions without having it mentioned in the signature.
Oh yeah.
Yeah, this was removed.
So this is JDK 8 docs I'm looking at. Thread.stop. We're taking a throwable. That is in JDK 8.
Yeah, so it's not there anymore in 11.
Really?
I think it's deprecated since 9 or something.
It's been deprecated forever. It's deprecated on 8. You're looking at deprecated right there. It should have been never. Okay, fine. Should have been never there. What it did, and if it's gone, then that opens this transformation up. What it did, it said that in the middle of running the fused loops, I could get hit with, if I took a safe point in the middle of running fused loops, I would have to stop and throw an exception where the JVM state was nothing that another thread could ever have seen. Right. Whereas if I do the synchronization rules are that counts as a hard, whatever you call it, a hard happens before relationship. So I can establish a happens before relationship by throwing a thread stop at somebody, and then investigate what they did and see the data now out of order. And your thesis, my thesis back in the day was I could go arbitrarily far out of order. Who cares? Right? Except here.
well, even in Java 8, your problem is gone. You can see it throws an unsupported exception if you try to send the other guy an exception.
In JDK 8?
Yep.
You actually just did, because it says deprecated, but that functionality
I pasted in the chat the implementation of the
version
that takes an exception.
That's the implementation in 8.
Yes.
Oh, interesting. Interesting.
Yeah, and it was deprecated for removal in Java 10, and it's gone in Java 11, it seems.
Yeah.
Okay.
So you don't have to worry about this
fully
problem.
at Azul. In fact, I did it mostly at Sun too. It was part of that at Sun. So there is an implementation other than that's efficient and well done, except for prevents the reordering of fused loops or arbitrarily distant memory reshaping operations. The other option is you never take a safe point or you never acknowledge the stop, but that sort of defeats the purpose of a stop. You have a long running operation that takes forever to run a billion element array doing something stupid. You have no safe points. Somebody wants you to quit. Stop now, stop. They can't get you to stop. You won't stop. They throw a stop at you. It doesn't work because you don't have it. So removing it means you can't stop them. The usual story is it's actually, you have a safe point now in your billion element loop, and the safe point at least acknowledges GC and class loading. But if class loading causes your loop to become untenable to carry on, you have to stop. And that's another fail. If I can take, if I fuse two loops such that class loading can defeat the functionality of the first loop, probably both. There's a way to recover if it do in the second. If class loading causes me to have to rewind and re-execute the first loop, in the fused world, I would have to re-execute knowing that the loops had been fused, and run them as if they were fused after class loading changed things. And you might be able to get into a zone where I can't acknowledge a loaded class. So this might still not be doable. This is ugly. Like suppose loop 1 said, for I equals 1 to zillion, make a v call, produce an answer, stuff it in. Oh, the v call only goes to one target, so I'm subject to class loading issues. And I inline. Now the loop says for I equals 1 to zillion, do some trivial thing and stuff it in. Okay, the second loop does the same thing. Oh, I want to fuse the loops. Okay, you know, the second loop reads from first loop, does some math and puts it back. That's a perfect candidate for loop fusion. Now I have a fused loop, which reads, does an inline v call that's depends on class loading, produces an answer, and it begins walking the array. Halfway through, a new class gets loaded. The loop says, I stop, I acknowledge a safe point, the class gets loaded, I have to unwind, go to the interpreter and rejit. Okay, the interpreter can't finish the loop out because he's got illegal state. There is no bytecode index representing that unwind operation. So you still can't do that. There's, damn it, you'd love to be able to do fusion here.
It would take more bookkeeping, but can't you unwind to the state where you're in just the first loop?
Right. So here I am. I'm busy writing. You know.
Well, by Cliff's premise, the state doesn't exist because you've computed the value the first loop would produce and
Crushed.
used it to produce the value the second loop produced, and you didn't remember the first one.
Yeah, you crushed the first guy in route. So loops were like read, modify, write on an array, and the second loop is read, modify, write on the same array. You run halfway through the first loop, we read, modify, write. It's like a stupid thing that you would never care for the answer. So you know it's okay to sort of mentally to say this is a bad case, but the semantics have to be well defined here.
Yep.
So yeah, so you crush the first loop, crush the first half of the first array, and you have half of the correct answer in the array again. Now you take a safe point, you stop, and you say, okay, I want to replumb where the meaning of V changes, but I need to start in the middle and run the second loop started in the middle. So there is some code I could run that would complete the semantic meaning of a few set of loops, but I don't have bytecodes for that. I'd have to invent equivalent bytecodes for the fused loop in case I flip to the interpreter, right? So let me make my case here a little bit.
Yeah, I
more.
definitely see the case. It's not dealing with two arrays; it's a single array, so you have no fallback there.
No fallback, and as soon as you have one with no fallback, you can have several with no fallback, right?
Yep.
Okay, so okay, so now I have two loops where they do a plus equals. There is no unwind. I've lost. Badly I want to fuse them, of course, and say A plus equals V1 plus V2 or whatever the correct, yeah, I think V1 plus V2. And then V1 blows out and becomes, it was X dot V1 where X was a loop invariant, but it changed because it was a global or whatever, fine. You did something where you denied X to be semantically correct upon a change and you had to go replumb the loop.
Yeah, well, I guess it depends on the nature of the change. If the change doesn't invalidate your assumption of what V1 and V2 refer to, then you can just keep going.
Yeah, right. No, it's class loading that V1 and V2 change. So all I'm trying to say is there exists a fail mode. Okay, we have to have a recovery path for all fail modes. You can't just crash the JVM on a class load. You loaded a class, oh, I did some code, I can't recover, I'm dead, boom, JVM quits. No, or it quits and just runs, gives you the wrong answer. Can't do that. Okay, you have to do something here.
But
what do you do?
Actually, I'm trying to think of a reasonable scenario where the class loading could affect this. Like V1, for the first half of the loop, V1 referred to the thing that it was before the class loading happened.
Right.
Same with V2. If the class loading changes, it
in the middle of an iteration.
Yeah, but it's not clear that the happen before rules necessitate that you need to start over.
Hang on. You said reasonable situation.
Yeah, okay, yeah, I did.
Go adversarial situation. The
Yeah.
evil adversary is trying to break you. What is the most cruel thing you can do?
But
Right.
these virtual calls,
Yeah, I wrote it sort of.
I mean, you have to imagine you've expanded your example a little bit so
Yeah.
that the
Yeah, let
reference.
me expand it. Here, I'll expand it right now.
But anyway, you have to be referring to something that
Yeah.
might change, which means the thing that might change needs to be observable by you. Right?
Okay, so here's a new example. X is some food thing, and it gets subclassed, and somebody stomps the variable. It's a static. It's a static global, right? Let me maybe expand the example a little more, right? So another thread's going to come crush you and load a foo, right? I'm not claiming this is good code. This is like stupid, but okay, fine.
Yeah, this is a bad idea, but yeah.
Yeah, right. I'm saying here's the evil adversary. The adversary says the JIT picks up X, says I will just confirm that it's unchanged each iteration of the loop.
So if X were not volatile, then maybe it is reasonable for the compiler to merge the loops.
Right. I'm not. Right. I'm claiming. Okay, there is a fail here.
Yeah. So
is there a reasonable path? So you're claiming that there is a solution. Some loops can be fused.
Right. And so yeah, maybe the rule is, it can't refer to anything volatile if we're fusing things.
You can't have a vcall that you can't have deopt information. Basically, you can't have deopt information in the body of the loop. Which everything that leads to a deopt situation, there are many things besides inlining a vcall that lead to a deopt situation that can be changed by class loading.
Sure.
Including, I knew there were two things and I put an if test for both. Now there's a third. I did a subclass test or an array store check that cannot fail. So I hoisted it out of the loop and now you loaded a subclass and now it can fail and on and on and on and on and on. So you go look at the core of C2, there are 100 places that you might throw in a deopt. You have to claim none of those apply in the first loop. And then you are not going to deopt in that first loop, period, end of statement. That is the definition of how the semantics go. I will not deopt. In fact, you can't deopt in the second loop because the deopt would see the work done by the first loop not done either. You cannot deopt in either loop.
Yeah. So that doesn't mean that this optimization won't find some useful things to fix. And
no, it would be entirely useful in a lot of contexts. I think people would have to write stupid code to defeat the test for correctness is difficult, but you have to try kind of hard to fit it, I think, to beat it. Any reasonable thing you could claim fusion on tight loops. So if the very complicated loops, you're just going to have deops and life, you lose. Simple striding array loops where you get the most performance from fusion, you can probably, maybe reasonably argue that there'd be no deops in either loop. Safe points for GC, but no deops. Fuse them, walk away.
So if you did the escape analysis and you look at this code and say, oh, I know that public static volatile X can never escape.
Yeah.
Can I just ignore the fact that it's volatile and say you said it's volatile, but it's actually local?
Yeah, it's all the as if rules all apply. It's as if it were local because I've already determined no one can see it. It's all good. Same for like knowing the arrays are local. If they're thread local, but I take a deop, but they're thread local, then I have a completely contained situation. In particular, if they're completely local, I can roll backwards in time and say, these two arrays are, no, I can't roll backwards. Shit, I can't roll backwards. I was thinking if they were new, if they were local and allocated new. So if they were made new in this function, new array A, do 3 or 4 loops in a row, you could go back to where you did the new. Your deopt could be unwind, all progress, go back. That would be doable too.
Which, at least in the case of the Scala's collection.map.map.map.map problem. All of your intermediates weren't nude. That was kind of the problem.
Yeah. Somebody starts the chain. They're not local. And if you side effect into the collection, then you can't unwind. You know, there's a whole yeah. Oh, X escapes. No, but you've inlined, Zen, the theory is you've inlined V1. If you have a V call in a hot loop, that's your problem right there. So you get rid of the V call in the hot loop. Now you've got a loop that has the inline contents, but has semantics of the V call such that if X changed, the new V call would go somewhere else. But otherwise, you're right, it would escape right there, and that would be, you know, crush done. Yeah. So Keith, you're basically promoting that there's a reasonable set of cases where you could actually fuse. I'm kind of coming around agreeing.
Yeah. But as you said, it's complicated.
It's complicated. That'd be no, I believe, knock on plastic, the rule is no deops in either loop. And
Yeah, although you spelled out an escape route if the
and
if you back up further than the first loop, right? So that new call or something like that, then you can,
unwind.
Move forward to where, people think you were and then carry on.
Move backwards. The other one you could do is deny the class load until you finish the loop. And that's the one that says, like, if X is not volatile, then like I just keep it cached in the register. And that actually happens right now. If X is not volatile, it'll just be cached in the register. So if you go stomp a new value down, not volatile, no synchronize, I ignore you. I keep the old value for the duration of the loop. Fine. And that's a legit story. You have something complicated where you have a loop with locking and you want to fuse them, and then you get all the locks to be parallel, back-to-back fuse. There's a bunch of gains to be had by fusing actually even complicated loops, complicated bodies. I could see all kind of progress here.
Things were much simpler back in the single-threaded world.
Well, yeah. Darn you, laws of physics.
I guess the last complete compiler I wrote was in university for Modula 2. And I'm still proud today. Like we had a Bootstrap compiler, obviously, and it would take like 3/4 of an hour to compile our compiler with it, but only 15 minutes with our compiler. So,
to compile yourself?
Yeah.
Yeah, good job. Yeah. Yeah, it's been a while since I've done a bootstrapping compiler. The last one of those I did was pre-Sun. It was a Motorola.
We didn't write the Bootstrap compiler, but.
Oh, you're right. No, I walked into an existing compiler group, and they had picked up somebody else's starter compiler, but we had long gone past that route. Like the company had been self-hosting its own bootstrapping compiler for a decade or more. And then one of your big performance tests was, can I compile myself faster than the last rev of the compiler compile itself? There's also a cross compiler. So I had all those funny, weird things. It compiled Windows to Mac and Mac to Windows to Linux versions, where /newline was auto replaced with, character newline or not, back and forth, according to whether or not you set flags saying, do the auto replacement on strings or character newline, make some people's lives easier. Except that because of the whole,
like if you're talking about C, that's just not legal.
Oh no, it wasn't legal, but people were excited about it back in the day as a porting opportunity. Take all strings where you saw /newline and cough up a character newline on Windows, and reverse that if you saw character newline on a Windows hardcore string, and all the string libraries would do it, and that was a flag you turn on or off. But you could cross-compile the Mac to the PC and flip the flag, and the cross-compile the compiler to itself, and then the self-compiler would be flipping the syntax the wrong way. It was the whole thing with you can't stop all backdoors everywhere. I don't know, Gödel's incompleteness theorem applied to CodeGen. Like the what was the one where the guy hacked the Linux kernel code and the compiler to insert a backdoor, and the compiler recognized when it was compiling the backdoor code. And when it was compiling itself, it would put in the backdoor code.
It's a trusting trust paper.
That's not the guy's name. Ken, the early hacker. Guy did C.
Richie, you mean?
Richie, yeah.
Ken Thompson.
Ken Thompson.
Oh, yeah.
Yeah. He was the guy who did this thing, and had a version where once he was done, the source code in this compiler did not mention having a backdoor. But if the compiler compiled itself, it recognized it was compiling itself and spit out code to look for a Linux kernel and put a backdoor in. If it was compiling Linux kernel, it pattern matched it as a Linux kernel and put a backdoor in. But then he removed that out of the source code. So the binary for the kernel had a backdoor, and the binary for the compiler would compile either itself, self-hosted, or the Linux kernel with the backdoor. But there wasn't anything in the source code about it. When you were said and done, that's the whole meta thing. Yeah, right. Yes, yeah, exactly. And
I remember encountering that and not being quite sure whether to believe it or not.
Oh no, it's real.
And
I ran into this at Motorola doing cross compiling of PC to Mac and Mac to PC for exactly character and line feed. You could get confused and have the source code say one thing, but the compiler was flipping it under your back, behind your back to the other thing, and not be in the source because you turn the flag on or off, and the flag was off. It shouldn't be doing any flipping, but the compiler had already been compiled where it's going to flip. Oh no.
That wouldn't be a language or a compiler I would want to use.
Sorry, my cat's howling and about to throw up. It's okay. It sounds like, demons dying.
You don't have to watch.
Well, everyone's waiting with bated breath, so it's done.
You're the only one waiting.
He's an old cat.
So at the risk of dragging us back to like null versus option, which we've done several times, we talked about the loop fusion. One of the cases where I see in Scala thing.map a lot is you have an option. You don't necessarily want to unpack the option. You have functions that take the thing and return the mutated thing, but doesn't deal with options.
Right.
And now you have 6 functions that all look at the option, unpack the option, do the thing, create a new option with the return value, open that option again, look at the option.
Been
Whereas
there,
if those
done
were
that.
all nulls,
It sucks. Well, no, but
like,
they're not all nulls. It's just horrifically slower. No, not hardly matters in the sense that the cost to pack and unpack exceeds many other things. You could be super expensive operations and then the unpack doesn't matter much, but you can quite easily get the spot where that's 90% of your overhead. If you're doing Daxby, Saxby style loops, I'm doing my stupid SQL queries where I'm doing if blah, 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 blah. Oh, multiply and sum, all the pack and unpacks, that's the cost. Not the multiply sum and nor even the query on what's valid or what's not. So, Scala options as a coding style maybe look good in some eyes. For me, it sucks, but it's fine. But the performance without fusing and grouping the unpacks, there's your problem.
But I think in this case there's not much difference compared to Java's optional. I mean, the semantics are a bit different, but from the boxing perspective, it's like Valhalla or you've lost.
I'm not claiming the semantics are different. I'm claiming the act of saying, if not null, load, do a little bit of math, allocate, oh, there's your cache miss right there, store waiting on the cache miss to complete, and lather, rinse, repeat. All your time goes to memory bandwidth and cache misses on the allocation of the new options. If you got rid of the allocation costs for the new options, the next 90% behind it would be the if load indirect, as opposed to an array which had the values in question.
Yeah,
plus
agreed.
A tag bit somewhere that said it's valid or it's not, which could be null or the element in question. I understand the value of having a thing which says it's missing, it's not available, versus it's available. Indirecting it through an option is like the expensive way to go. When you have
multiple return values are better choice than options, I would guess.
This isn't about multiple returns because I have an array of 1 billion things. And of the array of 1 billion things, many are missing, 50% are missing. If I put an option tag to sort the missing versus the not, then I have a 500 million option things. And that's the cost, right? So I have 1 billion doubles, half are missing. Okay, if I use nan instead of an option and lowercase double instead of uppercase double, I'll be 1/4 of the memory and 4x the speed before I count cache misses, which will turn into 10x the speed easily.
Mm.
So options on small counts, great concept, whatever, fine. Options on big counts, you need a different plan, or you need to be prepared to suck on a 10-fold slowdown. And I couldn't do that in a prior life.
Yeah, I think Rust did some interesting work recently where they have special types which mark the part of your value domain you want to use for it's not there. Yeah. So you have like basically like not sure, it's a stupid it's probably a stupid example, like have a double type which indicates that not a number is basically treated as like optional empty or something. Yeah. And the same for like integers, or like where you cut away the maximum -1, and it's really neat, but I think it requires a lot of compiler support to pull off.
So in the H2O land, we had to deal with missing numbers all the time, not a number not available. It was just a common data science feature. But we chunked the data, and so in any given chunk, you only had 1 million elements max. So we always picked another element that was not in any of the data in that million to represent the not available. So that you could always ask not available even on a full 64-bit. Like I have timestamps as long milliseconds, but I also had not available timestamp, and it didn't take anything out of the whole 64-bit range because compression strategy claimed there was always an extra one I could deal with. So there was a way to get it. I had a lot of goo in the system around to make that work. It wasn't transparent from the user point of view. You had to ask the question: is NA? And if you did a get me the long, it was an array lookup syntax like thing. Give me the value, and it was a long value. It was not available. We threw an exception at you. You are not allowed to go ask for give me the long value if it was not available. You had to say is not available and have your handling. What do you do if it's not available? Double nan has a particular handling baked into the hardware even for nans. Nans are never equal to each other, and they poison and whatever. And I don't know if you care if that's what you want on your nan, but there it is.
Yeah, and then the signaling versus quiet nans.
No, it's Java threw all that away.
Thankfully.
Didn't. Yeah. Back in the day when the pre-land of Java, whatever. Yeah, IEEE guys, did a good job and come up with the most general solution that solved everyone.
Yeah, I think that's an interesting problem Rust has, because they say we don't want to interfere with hardware or like with the settings too much. So basically they say, okay, we as a runtime don't want to disable signaling nans. They now have the problem that they can't cast bit patterns. For instance, like a 32-bit integer to a 32-bit floating point reliably, because there are bit patterns that cause the CPU to be very unhappy, because they decided they don't want to disable it, which I think is a valid choice, but it has a steep cost involved.
Yeah, it shouldn't.
I was talking for multiple return values, especially to handle options. Let's say you have a register, and the register signals that there is an exception, there is none, and you check the value in the register. That's much better than allocation.
Oh yeah, totally. Yeah. No, I'm totally for multi-returns, at least as a JIT implementation or a compiler implementation strategy.
Yeah, I mean that's what the optional ends up being if you have enough runtime support anyway.
Yeah.
So I think option in Scala and option in Java weren't designed with boxing forever in mind. So I think there was hope even back then that it gets elided.
Right now, I believe that there was an optimization that the checks returns it compiles to a Boolean check, but I don't remember which version implemented that. It won't allocate actually the option if you can implement as a Boolean check.
If you've inlined completely and do escape analysis, then you get it. But if you're crossing compilation JIT boundaries, I highly suspect that was not done. And had those guys back in the day talked to me about this, I'd have told them what would have worked and what wouldn't. It's fine. I had other issues with people like not talking to me, and then years later, it turns out they made a stupid decision, and I could have told them, and then why'd you come talk to me? And they're like, we did something. And I'm like, yeah, okay, you didn't talk to the guy generating your code, and so your code sucks. And are you surprised? Why are you surprised? JVM TI DIPI went down this path. We're going to come up with a cool concept. And I had, a cool way, efficiently, cheap, whatever, do all this profiling, do all this whatever work for debugging and ever. And they picked something else that was never, ever, ever going to be made go fast. And I let it go. You guys were coming with an API that was nonsensical in all ways. Profiling overhead was 10x what it needed to be and far higher than what you could usefully use. Yeah, fine. Not that I'm bitter or anything. Just water under the bridge. Multi-returns, option, yeah, optimizing option. There's a data structure optimization concept that's now important and didn't used to be important back in the day.
I think one important concept, which I am not sure what's so basically it's a bit like a strength reduction, but you're not doing it in the compiler you're not really doing it in the backend, but you're doing it during API design. Is to, for instance, you want to avoid having nulls somewhere either for safety or for performance because you decided you don't have nulls, you have options or something. And if you're looking at all the places where you can introduce nulls, for instance, you can do like a new array with size, and then you have nulls in it, and go through all of these things and say, okay, how can I reduce the strength of this operation by saying, okay, I have here like this there's array allocation, and then I fill it immediately. Okay, let's simply write a method for this use case, which does exactly that and guarantees me that the resulting array will never have null in it. And then you basically replace this magic powerful allocate array of size something with nulls with like 4 or 5 more restricted methods which can't do everything a new array allows you to, but have, I think, saner or safer semantics. And I think it's really. Sorry?
You have to be careful there about what you claim on your semantics, because the disallow part immediately defeats extremely important use cases that would kill the world if they went away. So you cannot just arbitrarily say never. You might have a good, a good case for certain pieces, certain style of codes. But if you're in the land of large concurrent caches, which every JDBC driver on the planet, every web server, every kind of concurrent thing does large concurrent caches, they are almost entirely backed by large concurrent arrays, which have no chance of not having nulls in them from time to time anyhow.
Yeah, right? Yeah, I think the idea is to nudge people into the right direction where it's possible. For instance, say, okay, if you're doing a simple array fill or like an array
Yeah, the other one, of course, is
Whatever.
just having arrays that are not that are very large, and you don't have all the data to fill them right now. You have no way to reorganize your computation such that you get all the data to fill the array right now. So for instance, an array list exists as an efficient data structure because half of the array is pending for future bits to land into, but there's nothing in them right now, and I don't have anything to put them in there. So I have to put a filler in them if it's, and what filler should I put in them? Well, null is actually a fine filler.
Yeah, the point is not restricting it on for implementation, but thinking about which kind of API is useful to 90%, which kind of API is useful, but also makes life easier for the compiler for the common use case. And then you have maybe 10% left over. And then the question is like, okay, array fill gives you an array of t, maybe new array of size of t gives you an array of option of t to punish people and to move them into the right direction.
You'd be punished.
Even better, the not the future part, it's behind the future of option of t.
Just saying, if you allocate, when you make the new array, if you also allocate some filler, then you lost. That was already too expensive. If instead you treat the nulls that you got for free, close for free, as if they were an option, because the JIT and the range runtime and the API have all conspired to say, this is a value, uninitialized, whatever. But you have to have a path where the baked down solution is no extra allocation, some single initial value, which is typically 0 because there's a lot of shortcuts or compiler optimizations to make that work.
That's something that really works well for reference types, because you can just declare, okay, null for reference types is like none of option. But yeah, then of course you run into the same problem for value types and have to think, okay, do I do something like Rust where you have like this non-zero of t, where you say, okay, 0 is my cheap, fast, none case.
You're kind of claiming or heading for the position of, I have an uninitialized value state, which I'm trying to make the language runtime not let you see in an uninitialized state. As opposed to, I can see it, but the compiler catches it, as opposed to, I accidentally got an uninitialized and I choked, which in Java, they fixed that by saying, you got a 0 instead of truly uninitialized. In C, you get truly uninitialized crap, random death happens. Java, you get 0 for your uninitialized. And that's an okay value in many contexts. And you can live with it, and sometimes you can just say that is the value and 0 is fine, and you go on. And then there's this notion of, I want to say, I have definitively described, I know this here, but not there. That's the array list where half of it is filled with something, and half of it is stuff I know. And here, up to length n, where n is not the array length, it's some subset, is actually initialized, and past that is not. And how do I do an API to describe that?
Yeah, I think the array list case is much simpler because you don't you don't leak the uninitialized contents to callers, which is a bigger problem for arrays if you want to go that way.
Oh no, I think you do. You can easily if you cheat on multi-threading.
Yeah.
If you do single-threaded behavior on a multi-threaded setup or something, the other way around, you do multi-threaded behavior on a single-threaded array list, you can clearly.
Yeah, but then all bets are off, right?
See, I claim that's a better problem to go solve. The better problem to go solve is to guarantee that you don't have cross-thread behavior. Better being, it's harder to solve and there's more gain to be had. It's a real problem because it's difficult. Make consistently useful cross-thread semantics somehow. And that's what Erlang was about. That's what all these people doing actors are about, where you're passing around messages. And you can make it very efficient in a lot of contexts and yada, 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 but no one gets to do cross-thread communication accidentally. They have to ask for it.
Have you looked at the Ponylang type system at all?
Yeah, I have. I mean, they're doing the right kind of thing.
Yeah, I wonder how much of that you could just learn. I know you talk with AA that you don't want people to have to type the types everywhere.
Yeah.
But if you can just learn, hey, this is isolated.
Well, a lot of that's sort of obvious. But yeah, I don't know. Maybe that might be a discoverable fact. It would be like, I want to say it's like almost textually discoverable is the limits, what you have to do there. So if you make something, it's clearly local. If you fill it with good stuff, you're local. If you publish it, where publish it has a special meaning and there's some syntax, I put it in a location that is known to be shared multi-threaded, and that's those locations are all carefully marked. So there's a publishing behavior you have to do. As soon as you publish, now it's public. But if you want to do a handoff, you have to claim I lost it, and that's linear typing a la Rust, which maybe is doable then. Yeah, maybe you could do this. So the two models are, it went public and I never get it unpublic. I handed it to just one dude as a producer consumer. And then I hand to a small set of dudes who somehow did something. I don't know if there's any gain to be had.
So when it's public, it's constantly synchronized?
No.
Until you make it non-public?
No. When a value goes public, I would claim that you would know from the language semantics somehow that you don't get the following rules on it. Like I want to declare a field final. If I publish it, I can no longer declare it final. I can declare it final before I publish it. After I publish it, I cannot declare it final.
But publish is a visibility, or it's synchronized, or it's both?
Well, it becomes both. So what you want to, well, I don't know what you want to do. What I'm thinking is publishing is an act that involves synchronization. If I recognize it guaranteed, then I can also guarantee some amount of synchronization. So I fill a pile of memory with good data. I take a pointer to it. So I'm filling an array with data. Take a pointer to the array and I publish the pointer. Can you see the good data I throw in this array? To do that, I have to have it happens before between all these stores and the store of this pointer and the load of this pointer, then the load through the pointer to the data, right?
So that's the whole data becomes visible at the point of
Right. So now, so as soon as you leaked a pointer to X, you leaked a pointer to everything X points to. And I can track that up to a certain level of precision, right? So I get some aliasing. As soon as I get confused by aliasing, I cannot tell anymore, and I have to go very broadly conservative. And you have a locally made foo that's currently local, and you only do local things when you store local, fine. And then you have an array of foos, and you publish all these foos, and I confuse them in the array in the alias analysis, and I say, you ain't local no more, dude. And you're like, but of course I am. And how do I mean, where do you go with that one, right? So there's limits of how far the compiler can go.
To guarantee the semantics of the visibility and synchronization.
Yeah. What are the semantics I can guarantee, and when do I give up the ghost and say horrible things to you, like, you want a local version of foo, you do something syntactically, you change your code such that you can guarantee, I can guarantee that it's local. I can prove that it's local here. I can't prove it's local there. As soon as you escaped, all the foos are lost. No final foos anymore. You're dead, right? Or no final fields inside of a foo or something. So there comes a case where I'm asking you to change your code so that I can prove that it's correct, which is what every compiler does. It's just that
it would be nice if the compiler could give you a lot of information. If I can mark some field as like, this is a local thing. And now if you lose the knowledge that the thing is local, you could give some kind of error that's like, okay, here's what happened that made me not able to declare it as local.
Yeah, totally, I can do that. If you flag it as it shall be local, and I see an escape situation, boom, you get an error message. That one's easy. If I deduce an error, an escape, and also I deduce, or you tell me it should be final, now I have to say it's not final because it escaped here.
Do you know a language that does that currently?
No language I know has it escapes as a part of the language semantics. This is, proposed. I think I can, but I haven't done it, so I don't know. Maybe. Like there are languages
Seems like
that
something
say,
high performance engineers would love to have.
Oh yeah, totally. I would love to have compiler support for this kind of stuff. There are languages which say the only way that you can escape something is you declare it up front as an escapable thing. So Clojure does, software transactional memory, and you have a ref. You have values and bars and refs. And refs are on purpose escapable and escaped, and all bets are off, and that kind of thing happen on a ref. So, but you syntactically said, and this thing escapes, and I give up on you know, sort of guarantees on the inside other than what you get out of the JMM basic guarantees. You do like Erlang, then you cannot escape something, so you can't ever even write it. That's sort of a interesting place to go because you can't make that mistake. But when you want to hand something off, you make I put it in the channel, and the other guy read it out of the channel. So conceptually, it got serialized to a wire, went through the other side, and got inflated. In practice,
But that is like a mailbox of observable changes. When it comes, you observe a value, a value, a value, a value. So the whole thing is serialized that way.
The conceptually, conceptually it's serialized. In practice, there are many cases where you can just hand a pointer off, but not in every case. And that model doesn't work for everything. So Erlang has a centralized database also, which is just like I was saying for your giant big web servers, GDBC drivers, and everything else. You end up with a central repository, which is concurrent, multi-threaded, safe to let people communicate that way.
But it does feel like at that point you want the type system to track your different types of pointers. To say either this is an immutable value, go ahead and pass it all over the place, nobody cares, it's not going to mutate, or this is a isolated pointer that's not aliased anywhere, feel free to hand it to somebody else, but you have to give up your reference when you hand it to somebody else. Or this is some kind of reference that is shared broadly locally, and you can't give it away because you don't know what other capable aliases exist in your local thread. Yeah.
I think Cameron has a semi-working, I don't know, I wish you were here, working situation there where they're doing.
And it feels to me like the type system is sort of where that should live, in the same way that a lot of people in the type system now have mutable.
Yeah, the more you allow your type system to permeate your program, the better you're off, because the compiler would help. The types are more semantically defining what is the meaning of what are you doing. The more you allow your type system to know about entities, the better you're off. In my opinion, of course.
Yeah. I'd like to not have huge type annotations everywhere. It drives me nuts, but generally there are a lot of types I wish I could talk about, but I can't explain to the compiler. Cross-threaded.
Such as types like?
Oh, anything to do with monotonic properties. I want to declare I have operators that are associative, commutative, or whatever, and have the compiler feel free to reorder or not, or tell me that it's not actually this because something horrible happened, or non-zero, right? Non-zero shows up not in Java, but now it's common in Clojure, and they're like, that's a good one. There are similar things where I want to say, like Pony does, this guy will escape or not.
So guys, I want to do a quick poll. What is a type to you? What does it mean to be a type in a program to you?
You asking me or you asking everybody?
Everybody who wants to answer.
I would say a type is when you have metadata about a block of memory.
Okay, I guess.
Okay, cool.
For me, I have concrete values, and a type is a collection of concrete values, probably infinite collection of concrete values.
Yeah.
Right.
Yeah.
That includes things like nil and not nil, and collections of not nils, and choices among values versus must do them all. So I have above and below a center line and a lattice. So I have choice versus all. Memory is totally included in that as just another value container. Nested. These are all nested as well.
Okay. To me, a type is almost the same thing. Like you talk a set of concrete values, so you can do a simulation, if you will. This type is a range of values, and I write my program according to this. Yes, but also there's a kind of synchronization properties because they prove your properties of the program in some way that allow you to reason about it.
Yeah. Separately from, you said synchronization. I mean, they get a lot of proofs of interesting properties out of typing. One of the things I haven't settled on is what is the multi-threaded concurrent set of properties that I want to prove on.
But do you want it as a type or as a properties of a problem? That's you say annotate a type like an option of T of a concurrent of T, or something like that.
Right.
You embed it in the type, the properties of the values.
I am currently embedding a huge count of properties in my types and kind of sort of extend them fairly broadly, sort of straightforwardly. So I am interested in continuing to add new properties to the types. Concurrency would be one way to do it. Locking games, this locks or it doesn't, or is being referenced in or out of the lock region or whatever. It's another property.
You think the language designer should pick the set of properties, or is that something for user space to decide?
I want it to get to user space. So, but in order to do interesting proofs, I have to say that what you can define as a property has some very strict restrictions on it. So give me a property that I can declare you a lattice. Okay, but I can prove that sort of straightforwardly for a simple enough description of a property. So you want to say something that's commutative and associative, whatever, that can fall into the lattice category pretty straightforwardly. And now I need a description language. I translate you to some embedded user lattice on top of my other lattice. It's more lattice, that's all fine. And then all other properties flow because I have a large lattice. So in what I'm doing, everything's a lattice of types. Or the types form a lattice, if you will, and there are many kinds of types in the lattice. If I throw in another type from a user, I do, and that's fine. I maintain my useful properties, including the ability to do type analysis in rapid, quick time to get you an optimal answer, right? Or get you the greatest common fixed point solution. So user types would be great.
The biggest thing I would change there is either to take memory out of the discussion, or
no, it's in
having your language a way to describe that, there is a representation somewhere.
Yes, I totally have memory in the typing system.
To reason about the memory as a type,
Memory as a type, yes.
Yeah.
But there are things you want to talk about that aren't necessarily represented in any particular way in memory, or not consistently.
So break out layout from abstract meaning. So there's an abstract meaning of I have a pointer to an array, the array has a length, the array has contents, or I have a struct, pointer to a struct has fields, fields have names, and names reference other things, or just like array indices represent other things.
Those are all rather concrete types, and so the question
no, these are all abstract values.
Abstract ones don't necessarily live in memory anywhere.
Yeah, so hang on. So what we're missing here is the difference between abstract and concrete of memory being an abstract intellectual concept and memory being a pile of bytes, right? So I say memory, it's because my expectation is the layout will involve memory, a real physical memory, but there's
not necessarily their location in RAM or such a thing. There's memory as a type, and other concrete entity in memory of your computer in RAM.
Yes, I am talking about memory as an abstract intellectual thing. When I go compile the code, I have to guarantee that I don't have two copies of memory at the same time, because I don't have enough memory for that, right? I physically shrink memory down to live in a 32-bit 4 gig space or however big. I can't have two 32 gig spaces, so I can't have two of them. So I have to be able to serialize my memory operations. So I have to have rules in the language that describe transitions between memory states that I can lay them out one after another as a series of loads and stores.
So at the end of the day, the abstract notion of a memory is at the last minute compiled to a concrete notion of a memory.
It's abstract all the way till the very end, and then I'll make it concrete at the last minute.
Yeah. Cool.
But when I say I have a memory, it has a collection of things that are made from news. Each a new thing is itself a collection of fields for structs or array elements for arrays. Each of those elements is now primitive scalar, but the primitive scalar can be turned into a chunk in memory, a physical layout, but I might choose layout options like repack the order of fields in a struct. I might choose byte encodings and bit encodings to get a denser format. I might describe the struct that you've allocated in memory. I locally see it never escapes. So the typing system it will keep it as an abstract struct all the way, but the implementation may inflate it into registers only and may only ever appear in registers. But if you did a Java SafePoint or a Java deopt, I could reverse it to some reasonable memory state. But from the compiler's point of view, it's an abstract typing notion all the way.
It's not. Okay, yeah, go ahead.
Are restricting the notion of type a little too much. Like I said, I don't think you need to have memory involved, and I'm trying to think of a good example.
Okay, I have to have it, and I can tell you why. So
Well, just
finish, but then I'll tell you why I must have it.
So the best answer or suggestion I've got is you think about sort of a generator function. You know, imagine you've got a function in your type system, and a particular instance of that type generates the Fibonacci numbers, you know, the infinite sequence, right? You don't have an infinite amount of memory to store all those numbers, right? And it doesn't need to live in any memory anywhere. It's not part of the type.
That's a generator, not a type, yeah.
A generator is something that your type system ought to be able to express.
No.
Okay, tell me why.
Not in that context. I can certainly describe a generator that has state because I have memory as a stateful thing, and I'm just carrying the state around.
No, the type is function, you know, taking no arguments and returning an int.
That would be the random number generator.
Yeah.
Which
the Fibonacci generator fits into that type.
A generator, any generator fits into that type. In the case of Fibonacci, you have internal state for what the next number in the series is. In the case of random number generator, you have internal state, which is the seed that you're using to shuffle.
Sure, both of those things have internal state, but
yes. And I represent internal state in the typing system as stateful.
The type doesn't dictate how that state is represented, and so I'm saying
That's
it's
correct.
Not part of the type.
The type doesn't dictate how it's represented, but the type knows of existence of the seed in the RNG or the next Fibonacci number in the Fibonacci generator.
I mean, maybe we're trying to split this a little too finely, but
we're talking maybe different things here.
The author of the implementation of the Fibonacci generator knows how he was going to manage the state, but the type doesn't know anything about that.
Yeah, we're talking at a different level here. So
the question was about types, and for me, the type is that more abstract notion.
Yeah, right. So I can have a function call that returns the next Fibonacci number and takes no arguments, except it secretly takes memory as an argument every time. It cannot be not taking memory as an argument. And there's its state. So no arguments, it has an argument. It's the prior state. It's not a mathematical function because mathematical functions are totally pure and cannot do what you said. There is no mathematical function which returns you the Fibonacci series as a mathematics statement of mathematical functions. Instead, they all say, I need an n as what number you're talking about. That's the purest mathematical. If I go to the abstract lambda calculus, the trivial lambda calculus, if I go to any of the algebraic domains, I must have that piece of state. It is.
I mean, there are, I don't know whether Fibonacci is still a good example here, but if you instead recast it as a function taking an int and returning an int, you know, the input argument is which one do you want?
Yes.
And the answer is the one you asked for.
Yes.
That one doesn't need to have any state.
That one, correct. That one in my domain, that one does not take a memory.
Okay.
I would start with it taking a memory and optimize it away really quickly and say it doesn't need a memory. It's a pure function. So no memory required. Yes.
Right. So whether a particular function
requires memory state or not
is the decision of the person implementing that an instance of that type.
Yes. But if you want to implement
part of the type,
if you want to implement a type that takes no memory, it is de facto pure. Right. And cannot return a different answer on subsequent iterations.
Which, by the way, can be
time of day takes a memory.
Time and date has a hidden side effect that I don't typically call memory. I call it I/O. there's the real state of the memory. We put a lot of extra meaning and context to, but in the mathematical largest sense of the world, there is no distinction between memory. It's the memory of the universe. IO is the memory of the universe. Time has marched forward. The missile has launched. I pressed the red button and the missile launched. I can't unwind, right? So there is another version of state, which is the memory of the universe, that I don't typically represent, but I have a special hook in the system to say, this guy invents from whole cloth some value. He doesn't have a memory. So the implementation at the hardware level needs something besides the hardware CPU and the hardware memory. It needs another thing. In the case of memory, in the case of time, it needs a clock. He has to go ask the hardware for a clock, and the hardware holds on to a clock. That's another piece of hardware. It's part of the CPU. So
Again, that's going to prevent you from serializing that object.
you can serialize a timestamp, not a timestamp, serialize a thing that produces time. You can't.
You can't serialize the universe that you just said was included.
Exactly. You cannot roll back time. So you can't write it down to a disk as a pile of the universe and then load the universe back up. And I went back 20 years because I want to be a young man again. Makeover life changes different. No, it can't be done.
That would be a cool function. Yeah.
Exactly. But we don't have that one. Fine.
Not yet. Not yet.
Not yet.
So the IO type is how you can prevent a system from trying to move something. I may have a way to like move this closure from one computer to another computer, but I can't move this closure to another computer if it's closing over, read the thermometer at this weather station.
Yeah.
That's not a thing you can move to the other node. Like,
Right.
Sorry.
Right. Exactly.
Yeah.
That answers a bit of my my question, because I was wondering the whole time. Basically, my definition of types is basically any kind of information that reduces the valid set of programs the compiler allows you to compile, and
A valid set of programs or values? Programs or values?
Programs.
It turns into
and that's basically that's that point of saying, okay, we have types, we have this memory type, and now there's an actual effect where having this memory type makes the compiler reject writing code, moving functions across different systems. That was the point. That was okay. Now
but that applies a non-determinism. You can totally have a non-determinism as a type. Nothing prevents you.
I don't want to reason on them, not very much, or I want to constrain the non-determinism to do reasonable reasoning on it. But yeah, you could have it. This is what a random number generator is trying to do, but we implement them with state.
This is why basically the Haskell implemented all its side effecting in one type and the IO type, and then wants everything else to be totally non-side effecting, pure functions, blah 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 blah. Because the IO type encapsulates all that mutating state away from it.
Yeah, I understand why the IO thing exists in would you say Haskell? Haskell, right? Yeah.
So I'm wondering how Haskell would look like if they had a more granular separation of effects. So they would have like networking effects, or effect including randomness, or effects of saying, okay, this thing goes to console. How it would change the APA, I am.
It can totally encapsulate an IO of network effect to IO of console effect. That would encapsulate coming something from the network to the byte and printing it to the console. Like for example, it wraps the type you are affecting, and you continue.
Yeah, that's the level of memory that I'm thinking about when we're talking about these things that you can wrap up to some limits of size and space and reason about within the box, if you will.
Are the attributes that live in the time system parameterized, or are they essentially all bools?
Abstractly, for me, they're all pools, I guess. So when I do
my thought is, if I have a range, I know this number is 3, 4, 5, or 6.
Yeah, totally, it's fine.
I can have one Boolean fact, which is it's equal or greater than 3, and one Boolean fact that is it's equal or less than 6.
Right. So in the realm of AA, not in general, the how I describe types is sort of any arbitrary function I want to do to describe ranges of different kinds of things. One of them would be I want to describe a range of integers. One of them would be I want to have a lower and upper bound on a Boolean, but I wouldn't parameterize it that way, because in order to maintain my lattice property that leads to the efficient and also at least to actually a single correctness leads to a single best type. If you don't have a single best type, you can't type a program. You get two different choices, ambiguity. So there are limits to what you can describe, but they're pretty broad. So range of values is easy. So range of subtypes is easy. Null or not, that's just like a range of values. It's this or it's not this. I do function code pointers. I do, like I said, memory states, which just you can nest them arbitrarily, however deep you want to go. Things you would call tag unions, sets of aliases, sets of function aliases, call graphs. I actually do returns, which leads me into continuations, also fit right in.
Would it be sane to put kind of arbitrary user functions there?
Well, that's what
this is a subtype of int64 where the int64 is the user ID of a user who has admin rights.
Where the user, okay, so you would have to claim the type where has user rights, a sort of arbitrary general function. This is an int64.
I would pass in an oracle to the type system in some way that says, here is your test for, is this an admin?
The oracle can't change over the execution of the program. So I'm going to run it once and get an answer out, and then it's a constant.
What if it changes in one direction? I say, once an ID is considered to be valid, it will never become invalid again. Right. But once something is invalid, it may become valid at a future point because we created a new user.
Right. So then you get a lattice of false to true, and the oracle starts you one time at the beginning at false or not, and then it's false or true, and I have to do a runtime test. Now I have to have a runtime test. Have I flipped a bit? Right. So whenever you bring this oracle along, when I do a typing analysis, in some places he says no, in some places he says maybe, right? When he decides it's time to flip his state from one thing to the other, even if it's monotonic, all I can say is you had to handle that in your code. Like the typing tells you, and here you have to handle the case where he said no, and now you want it, it's either no or yes, right? You have to handle. If once I know it's yes, it's always yes, then the typing system can handle, I passed through a yes test once, no more questions have to ask again. Same as like casting. I have an object, capital O object, I cast it once to foo, I cast it 17 more times to foo. After the first foo test, I don't have to test it again. Null pointers, I test it once for null, it's not null, I know forever it's not null, down that path, right? But there is a test for null. So I need a runtime test where I query the oracle at runtime. And once I've passed that, I don't have to ask again. That's doable.
Right. So I could have deeply nested functions that only operate on admin users.
Yeah.
And I first go from a user context to an admin user context. I have to do a check then.
Yeah.
But after that, I know it's that type, so I can ignore all the rest of the checks for lots of code and not pay that performance cost of admin checking over and over and over and over again.
But that one is what you get out of any other regular typing system. You do that in Java. Scala, Haskell, all these guys, right? As soon as you said, I am an admin, you got a runtime test. Then you have a function that only takes an admin, and therefore it's only got an admin, and you have deeply nested piles of admin-only things. It's all good.
But in Java, I have to have two types.
You have to have two types. You have to have, you end up with three. You have, I could be a left or a right, and then I'm a left, or I'm a right. So one of them says, I'm in the options world, I'm just a foo, I'm nothing, or I'm an option. You get three things.
But if it's a higher kind of type, it can be an option of a just of a foo.
That's these things, however deep you want, it doesn't change the quality, or it doesn't change the behavior of the typing system. All these things have a self-recursive loop in the meta description, if you will. For me, I call it scalar, bottom out of the scalar. I can't nest a memory in a memory. Memories contain objects. Objects are either arrays or structs. These arrays and structs have field elements. Field elements are scalars. Scalars can be pointers to other objects, but they can't be another memory. So I don't nest a memory in a memory.
When you talk about an int, can you attach a memory about an int to talk that it's a 32-bit int when you begin to talk about memory? So you can reason about it more, the compiler can reason about it more tightly, let's say.
I missed the context between memory and int. I can certainly describe 32-bit ints.
Yeah, but at the compiler level, at the type level, yeah.
Type level.
Yeah.
You know what, the compiler, you understand? Compilers understand 32-bit ints. Totally. I mean, the code gen side, there's typing system understands 32 versus 64 versus 128 versus big int, right? You come down to the code gen side, generally speaking, you understand the difference between 32 and 64 and 16, 4, 8, 2, 1. They're all different things at the code gen level.
The compiler only can tell at the type level the difference between an int and a long because they're different types. They cannot reason about that. One is a 64-bit and one is a 32-bit, I believe.
Why not? We do all the time. We've been doing it for years. Yeah, you go through a phase where you know, only in C is int have variable length. Once you get the length sorted out based on programming flags and data models, whatever, and int's 32 bits or it's 64. So now you have int 64 and int 32 and int 16, 4821, or variable however many bits you're going to have in your int. That's all entirely reasonable. When you go down to cogen, it's exciting to deal with 1 bit, typically 8, typically 16, and powers of 2 up to the limit of the hardware, because they'll have special loads and store ops for each power of 2 and something for bits. So those are all exciting at the hardware level, but at the typing system, and it is a pile of bits of whatever length, and I do lengthy things with them. So you can be 32 or not. Typically, it only does things like, I agree that when you add two 32-bit numbers, I ignore the overflow.
That's what my question was.
Yeah.
At compiler level, you can catch that overflow.
Yeah, at the compiler level, at the typing system level, the type of add of 32 is two 32-bit ints go in, one 32-bit goes out. It's just like a function takes two ints, produces an int. It happens to wrap and throw out the overflow bit. There are languages where the behavior is different, where they blow an exception if you overflow.
That was my question initially.
Yeah, there are languages that blow an exception for overflow. There are people who, instead of blowing an exception, they auto inflate to big integer, right? I want to say JavaScript does that, but maybe they overflow to capital D double. They were not capital, they overflow to double maybe.
JavaScript solves the problem by not having ints. They only have floats.
Yeah, they don't have
okay, fair enough. Right. So the presentation is up to 2 to the 53, and then you flip to floating point presentation. I'm sorry, York, you're about to say something? No?
Yeah, no, I was going to say, I believe they don't have big numbers because of
they recently added a big int type, but it's I think a completely separate thing from like it's a real class with like methods on it, and you have to create it explicitly.
Put it at the end of a literal, it says this is a arbitrarily large big int.
Yeah, there's I think no automatic promotion going on from the existing floating point numbers.
It's always doubles.
Ruby does have automatic overflowing. They up until I think a year or two ago they had overflowing, but the types were still different. So you had an integer, it started as an integer type, it would get too big and it would turn into a big num. But since then, it's now just the same class for both. In my language, I actually have that too, but I am considering ripping out the automatic overflowing, because it just adds quite a bit of boilerplate for the arithmetic. So for every integer operation, you have to do like, oh, if on the left we have a big int, on the right a normal one, promote that right one to a big int, then do your thing. And do it the other way around and handle when they're both big ints. And I ended up implementing basically this through macros. And you also have to take into account shifting with big ints. And so I ended up like one file, I think it's like 150 lines of macro code, which is then repeated for 15 something numerical operators, whatever the number is. I believe last time I checked, it was a sizable portion of my VM code was just the integer overflow handling.
Yeah.
Not
Why
fun.
is it that even if you never overflow, it is still so slow to work with auto-promoting ints?
Because you have to
Exactly.
test. What's the cost of an integer add on an x86? You tell me. Tell me what number, and I'll tell you if you're right or wrong.
One cycle.
I would guess a quarter of a cycle.
Yeah, quarter cycle is more correct. Okay, what's the cost of a test for overflow?
100 cycles.
My assumption was that when I do the add, I can register some kind of interrupt handler for the overflow that will, the hardware will then do the interrupt, same as like a null check where I
no
dereference
hardware
the
interrupt
thing.
on overflow.
You basically introduce a branch into all your math logic, and I think that's extremely expensive.
There you go. You have to test for overflow bit every fucking place on the planet.
Yeah, and in my case, like that part played a role, although that kind of performance, at least in my case, probably isn't going to matter for like the next 5-10 years anyway.
Okay,
but it's more the code size of things where I look at it, I just go like, ugh, like no, this is not something I want to keep.
If you've already specialized down to where I know I have small int coming in, I'm doing a math, I just need the overflow check, that's already a 4-to-1 slowdown.
So the reason for null checks this isn't expensive is because the TLB hit was you were gonna pay that on dereferencing anyway.
The null checks are not expensive for a couple different reasons. So in the land of Java, 90% of null checks that are statically written by the bytecode, like every bytecode does a null check all the time. 90% of those get removed by the compiler upfront because you did it once and the remaining were all provable, not going to happen again. Unlike in arithmetic, where every arithmetic operator might blow you out. So you get a 10-to-1 ratio division right there. The next piece is that half of the remaining are done with a memory op, a load or a store, that will throw an exception if it does. But if it does not, the hardware is highly optimized for it and costs you nothing other than the load and store, which you had to do anyhow. So it costs you 0 extra for the memory check. The 5% that's left over, those you paid the half a clock for a null check test that typically didn't fail. 1 clock, something like that. Depends on how you count a predicted branch that's easily predicted. The overflow checks probably, if you aren't actually overflowing, predict easily as well. So they're probably only the same half a clock. You do a jump on carry to fail, and you just never jump in the hardware. And if you do a forward branch, you have to do these all forward branches. There's all kind of stupid tricks you have to do, by the way, to make it actually pan out that way. You have to be forward branch because if you do backwards, the hardware has, and he's never seen the branch before, he makes a prediction based on forward branches are not taken, backward branches taken. Once he's seen it once, it goes in his branch target buffer, and the next time around, his branch prediction table, next time around uses the predictions he has. The problem is in any large code space, you blow out that branch cache. So you don't want to fill the branch cache with branches that are easily predictable by you. So if you suspect you are not overflowing, you want all those branches on overflow to only go forward so they don't populate the branch cache on the CPU. Then you have to arrange all your code layout such that you only have forward branches after every arithmetic op up to some finite limit of a branch range. And then you have the catch place that says, in fact, it blew out, now I have the deal. And the loads, because of the 10-to-1 reduction in load the 10-to-1 reduction in nulls, you're less likely to have an issue with having so many targets of branches that have to be dealt with that you run out of branch range space and have to start screwing around with catch pads for the targets of the overflows, and then start up your forward flowing code again. It's a harder problem, and it happens in the worst case a lot more often. And you don't get the nice 10-to-1 reduction in the beginning, 20-to-1 after you count the load and store hack. And that's why it's more expensive. All right, we are approaching noon. I have to deal with lawyers and the tax people today. And I have to pay my bills too. So I'm gonna have a full plate. So I'm gonna call it now. It was a fun chat, and I'll have to think about your concept of sorting on the hashes as a way to sidestep the expensive sort key compare step. I like that one, and fix the distribution problem that you would have on get a random distribution. That was a fun hack. Who threw that one out?
That was me.
That was Aaron.
Also,
Yeah.
I recommend reading the Kademlia paper because they talk about this trick a lot.
You throw the Rendezvous hash in Wikipedia. It's in the middle of the chat.
Yes.
Is there a paper too? You have to throw the paper out.
Let me see if I can find it.
Yeah, if you don't, you don't. I'm gonna call it because my wife just made some nuking lunch and now I'm hungry. lunch is gonna win. All right.
May I offer a question which we may think about for next time?
Sure.
I would offer the question modifiers and annotations. Do we need both, or can we get rid of one of them? And everybody who is interested is invited to maybe think about it and tell us the answer next week.
I don't know what you mean by modifiers, and I think annotations are annoying, but maybe next time. Okay.
Yes.
Nice seeing everybody. Nice, good conversation. Twitter will be a little bit late this time around because I got a handful today. Okay, bye-bye.
Bye, guys.